1953. On paper, it looked like a victory. In the shop, it was a civil war. By 1957, Massey Ferguson isn't just bleeding cash, it is rotting. Acres of brand new machines left to rust in the rain. They call it the Ghost, a $182 million graveyard that threatens to liquidate everything. The board wants to fold. One man doubles down. Albert Thornbrow bets the company's life on a $30 million suicide mission called Project DX. The goal? Build one universal machine for the entire planet. But how did a company on death row build the unkillable tractor that still feeds the world today? To understand the miracle, you have to understand the dysfunction. The Civil War wasn't a metaphor, it was a clash of religions. You had Canadian executives, guys used to building massive harvest giants, butting heads with British engineers who treated Harry Ferguson's hitch design like scripture. It was a shotgun wedding. The chaos was total. You had dual distribution networks fighting for the same customers and competing product lines cannibalizing each other. The factories couldn't even agree on the basics. You had one half of the company using imperial bolts and the other half using metric. The result was that $182 million ghost. The money men at Argus Corporation had seen enough. They fired the leadership and installed Albert Thornbrow to clean up the mess. Thornbrow didn't panic. His first move was a fire sale. He liquidated that rusting backlog, turning the Field Queens back into cash. But he knew that selling old stock was just a band-aid. He looked at the map and realized the trap. The North American market was mature. The big farms in the US and Canada were already full of iron. There was no room for growth. To survive, they had to leave the West. He bet the company's future on the developing world. South America, Africa, Asia. Places shifting from ox power to horsepower. But to run a global operation, you need a universal heart. In 1959, Thornbrow bought Perkins engines. This was the turning point. By bringing the engine supplier in-house, Massey Ferguson secured the power unit. They now had a standardized diesel engine that would become the rhythm of global agriculture. Finances stabilized, engine secured, now came the gamble. In 1962, the board greenlit Project DX, Detroit Experimental. The budget was $30 million, the biggest single investment the company had ever made. The orders were simple but brutal. Build a world tractor to replace the aging 35 series. The engineering team clocked over 1 million man-hours. They faced a tough choice: reinvent the wheel or refine it. If Project DX failed, the company folded. No backup plan. They chose evolution. They kept the legendary Ferguson hydraulics because the system worked. It put the weight where it belonged, on the rear wheels. But everything else, the chassis, the transmission, the ergonomics, they decided to heavily refine it and standardize it for a global stage. The goal was a machine built simultaneously in 3 countries using interchangeable parts: Detroit in the USA, Coventry in the United Kingdom, and Beauvais in France. This was a logistical nightmare. A transmission case cast in Detroit had to mate perfectly with a rear axle machined in Coventry. A hydraulic pump built in France had to bolt straight onto a chassis assembled in Michigan. We aren't talking about close enough. We are talking about precision tolerances on a global scale. This level of standardization had rarely been attempted in the automotive world, let alone with heavy agricultural machinery. Thornbrow was betting the farm that one design could work for the corn farmer in Iowa, the dairy farmer in Devon, and the rice grower in India. The blueprints were dried, the factories retooled, and the $30 million wager was on the table. The civil war between Massey and Ferguson was over. The mission was the 100 series. The design was ready. Now they just had to prove they could build the actual thing without going broke. To build the future, Massey had to admit the truth about the past. Their flagship, the MF-35, affectionately known as the Fergie, was a legend. But by the early 60s, it was a relic. Mechanically, it was sound. Ergonomically, it was a torture chamber. The operator was exposed, cramped, and rattled to the bone. The board had a choice: scrap Harry Ferguson's legacy and start over, or double down. They chose to double down. They kept the hydraulic heart that farmers trusted, the 3-point hitch, but they completely revolutionized the chassis. They weren't just building a new model, they were engineering a survival strategy. That strategy rolled onto the floor of the Smithfield Show in London in December 1964. The company pulled the sheet off the 100 series. Standing front and center was the Massey Ferguson 135. It didn't look like the biggest machine on the floor, but it cast the biggest shadow. It was the Goldilocks tractor, compact enough to squeeze through the door of an old English barn or navigate an orchard, yet heavy enough to put serious horsepower to the ground for plowing. But building it was a different beast. To pay for the development cost, Massey devised a manufacturing web that was astonishingly complex for the time. The 135 wasn't just built in a factory, it was a global citizen. Banner Lane in Coventry was the heartbeat, churning out hundreds of units a day for the Commonwealth. Detroit ran lines tailored for North American row crop farming. Beauvais in France handled the specific safety codes for Europe. There was even a silent partner, Landini. Down in Como, Italy, they produced the narrow vineyard variants that nobody else wanted to touch, ensuring the 135 DNA could navigate the tight rows of the Mediterranean. This global ambition created a massive headache for the engineers. The markets had radically different needs. You couldn't just build one world tractor and walk away. Take the front axles. American farmers needed adjustable, swept-back axles to change their wheel track for different crop rows. The British and Irish markets, they didn't care about row widths. They wanted the brutal simplicity and strength of a straight fixed axle. The platform had to handle both without effectively becoming two different machines. What finally united these different worlds was the tin work. Before the 135, tractors looked like overturned bathtubs, round, bulbous hoods that belonged in the 50s. Project DX killed that look overnight. The designers introduced a sharp, angular aesthetic. They squared off the hood and introduced the wasp waist, a deliberate tapering of the sheet metal near the dashboard. This wasn't vanity, it was visibility. For the first time, the operator could look down and see exactly where the front wheels were tracking. That is a massive advantage for precision cultivation. The flat-topped fenders and aggressive rectangular grille made the machine look purposeful. It made every round-fendered competitor on the Smithfield floor look like an antique. The design drew the crowds, but once the farmers stopped staring at the sheet metal, they started asking about the machinery beating beneath the hood. A farmer defines a tractor by the noise it makes when you turn the key. With the 135, that sound depended entirely on which side of the Atlantic you were standing on. If you were in Europe, the heart of the machine was the Perkins 83.152. This 3-cylinder 2.5-liter direct injection diesel was the gold standard. It put out 45.5 horsepower, but the numbers don't tell the story. The torque did. It had a distinctive rhythmic thump that you could identify from 3 fields away. The Perkins was unkillable. It ran for thousands of hours on dirty fuel with minimal maintenance. It made a small tractor pull like a big one. But the American market told a different story. In the early 60s, diesel availability in the States was spotty. Plus, farmers in the Midwest hated fighting to start a diesel engine in a frozen January. They wanted a gas engine. So, Detroit fitted the 135 with a Continental Z145. It was quiet, it started instantly in the cold, and it ran smooth. It was a civilized engine compared to the raw industrial clatter of the Perkins. This created a split personality for the machine, but regardless of what was burning the cylinders, the real magic wasn't how the power was made. It was how that power got to the wheels. The standard transmission was a robust, basic gearbox, but if you were willing to pay for the upgrade, Massey sold you the multi-power. This system effectively doubled your gears, 12 forward, 4 reverse. It worked using a hydraulic splitter and a multi-disc wet clutch. On the dash, you had a simple switch, high and low. Flipping it to high jumped your ground speed by 30%, but the real advantage was that you could shift under load. Picture it, you're plowing deep, you hit a patch of tough heavy clay, the engine starts to bog down. On a standard tractor, you have to stop, declutch, and grab a lower gear. Momentum killed. With multi-power, you just flip the switch. The hydraulic clutch drops you into low range instantly. The torque spikes, you power through the clay, and once you're clear, you flip it back to high. It turned a stop-and-go struggle into fluid motion. But there was a catch, a dangerous one. In low range, the multi-power system provided zero engine braking. It was like a bicycle hub. It would freewheel. If a rookie operator crested a steep hill in low and took his foot off the throttle, the tractor wouldn't slow down. It would take off like a bobsled. It was a feature that separated the operators from the steering wheel attendants. That system came with a hidden bonus called hill hold. The engineering relied on a mechanical conflict within the gearbox. When the selector was in high, the hydraulic clutch was engaged. If you stopped on a steep incline and depressed the clutch pedal, the tractor wouldn't roll back. This wasn't because of engine compression. The clutch had disconnected that. It was because the moment the wheels tried to turn backward, the internal gearing of the high range fought against the one-way sprag clutch of the low range, effectively trying to turn the transmission at two different speeds simultaneously. This locked the drivetrain solid. As long as the engine was turning to keep the hydraulic pressure up, it acted like an automatic parking brake. You didn't need 3 feet to juggle the pedals. You just let out the clutch, the bind released as the wheels turned forward, and the tractor pulled away without rolling back an inch. Of course, engines and transmissions are useless if you can't put the power to the dirt. This is where the Ferguson system draft control proved its genius. Here is the physics problem. A light tractor struggles to pull a heavy plow. The wheels just spin. The old solution was to add dead weight, cast iron wheel weights, or water in the tires. Massey used leverage instead. The top link of the 3-point hitch wasn't just a mounting bar, it was a sensor. When the plow hit hard soil, the resistance pushed against that top link. That pressure signaled the hydraulic pump to lift the implement just slightly. This did 2 things. First, it kept the engine from stalling. Second, and this is key, it transferred the weight of the plow and the soil onto the tractor's rear tires. The plow wasn't an anchor dragging behind you anymore. It became ballast. The harder the pulling got, the harder the tires were driven into the ground. This allowed the lightweight 135 to outpull competitors that weighed twice as much. The combination was lethal. The Perkins torque, the shift-on-the-fly multi-power, and the physics of the draft control made the 135 the undisputed king of the 1960s. Dealers couldn't keep them on the lot. From Iowa to India, the Red Giant seemed invincible. But the capabilities of this machine were too vast to stay in the furrow. The 135 was about to leave the farm. By the mid-1960s, the 135 began to shed its traditional red coat for highway yellow. These were the MF-20 and 2135 industrial variants. These weren't just farm tractors anymore, they were municipal workhorses. You'd see them mowing road verges across Britain, towing baggage carts at Heathrow, or in some cases, pulling F-4 Phantoms and Avro Vulcan bombers for the Air Force. The chassis was so versatile that engineering firms like Roadless began grafting heavy-duty front axles onto the frame. They turned standard machines into four-wheel drive unicorns, designed to conquer the steep, snowy gradients of the Alps where a standard rear-wheel drive couldn't tread. But while the 135 was conquering the tarmac, a shadow appeared back on the farm. A blue one. The Ford 3000 rolled out to challenge the Massey supremacy. This wasn't just a sales rivalry, it was a clash of engineering religions. Ford bet on brute force. Their 3000 weighed in at 3,700 pounds, about 700 pounds heavier than the Massey. Their logic was simple. Bigger is better. Use dead weight to push the tires into the dirt. Massey stuck to the ghost of Harry Ferguson. They kept the machine light, around 3,000 pounds, and relied on the Ferguson system and the differential lock to create traction. To the uninitiated, the Massey looked frail next to the beefy Ford. But in the field, that weight difference was critical. When conditions turned soft and wet, the heavy Ford often became a victim of its own mass, sinking into the mud like a stone. The lighter Massey, using the plow's resistance to drive the tires down, would float over the surface, keeping traction where the blue rival was left spinning. However, the battle wasn't one-sided. The Ford had a weapon that made the Massey look ancient: live hydraulic. The Massey 135 used a Scotch yoke piston pump. It was a marvel of high-pressure engineering, giving the small tractor a massive lift capacity of 2,850 pounds. It was a giant killer for plowing, but it had a fatal flaw. It was driven by the transmission. Unless you had the optional 2-stage clutch mastered, the moment you stomped the pedal to shift gears, the hydraulics died. Even with the 2-stage clutch, doing loader work was a constant leg workout, feathering the pedal to keep the pump spinning while trying to stop the wheels. Ford took a different route. They mounted a gear pump right on the engine. The hydraulics were live. You could clutch in, stop the tractor, and the loader would still lift at full speed. For a guy doing loader work all day, the Ford made the Massey feel like a relic. The Ford also won on comfort. It offered a wider, more sustainable platform that felt less like a perch and more like a workstation. On the Massey, you were intimately acquainted with the machine's mechanics. You had to straddle the transmission tunnel like a jockey on a small horse. You sat with the gearbox spinning between your legs. In February, that radiating heat was a heater. In July, during a long day of hay baling, it was a curse. Yet, despite the heat and the clunky hydraulics, the 135 won the war. Why? Because the world is bigger than a clean American cornfield. In the developing markets, India, Africa, and the Outback, nobody cared about a flat floor. They cared about survival. The Ford's sophisticated systems were great when they worked, but the Massey's simple Scotch yoke pump could be fixed in a field with a wrench and a hammer. It ran on fuel that would choke a sensitive engine. Its light footprint didn't collapse the fragile terraced fields of Asia. The 135 proved that while comfort is a luxury, reliability is a necessity. The little red tractor had survived the mud, the heat, and the Ford Motor Company. But there was one force the 135 could not outmaneuver with draft control. It wasn't a rival manufacturer, it was the stroke of a government pen. The era of the open-air workhorse was drawing to a close, and the safety inspectors were about to change the silhouette of farming forever. Before the regulators could box it in, the chassis evolved into its most aggressive form, the yellow fleet. Between 1969 and 1975, the MF-20 stripped away the last pretenses of agricultural gentility. If you look closely at these industrial survivors, you'll notice they abandoned the familiar slatted grills of the farm models. In their place, the MF-20 featured a hard nose. This was a solid steel plate, punched with holes for airflow. It wasn't cosmetic, it was a shield, designed to protect the battery and radiator from the inevitable impacts of a construction site. And while the farm tractor sat on adjustable axles for crop rows, the MF-20 sat on a massive straight-beam steel axle. It was non-adjustable and built to handle the immense stress of a front-end loader without buckling. That over-engineered frame found a home in places you wouldn't expect, like the tarmac of a Cold War airbase. The Royal Air Force and the USAF deployed these machines as ground tugs. We're talking about a 3,000-pound tractor moving a Blackburn Buccaneer, an F-4 Phantom, or even the massive Avro Vulcan bomber. You might wonder how a little tractor moves a strategic bomber without stripping its gears. The answer is torque multiplication and ballast. They filled the rear tires with calcium chloride, stacked wheel weights to the limit, and used reduction hubs to convert engine power into sheer immovable traction. It proved that a drivetrain designed to plow clay was equally adept at positioning air power. But that raw connection to the ground, the low center of gravity that made it stable, was exactly what the safety inspectors were about to ruin. The turning point was the Agriculture Tractor Cabs Regulations, 1974. Government bodies realized that the rhythmic clatter of a diesel engine was deafening farmers by age 50. They set a strict noise limit of 90 dBA effective June 1, 1976. To sell a tractor in the UK, you effectively had to seal the operator in a soundproof box known as the Q cab. For a big 100 horsepower tractor, the cab is an upgrade. For a compact 135, it was a disaster. Engineers were forced to bolt heavy, expensive cladding onto a frame that was never designed to carry it. The sleek wasp waist was buried under angular frames and glass. It raised the center of gravity, making the machine feel top-heavy on steep slope, the very terrain where the original design excelled. The romance of the open station, hopping on and off to check a fence line, was gone. You were isolated behind glass. Safer for your ears? Yes, but it killed the nimble character of the machine. Recognizing the end of an era, Massey released a final tribute. In 1977, the North American market got the Silver Mist. Finished in metallic silver with red decals, it was the swan song for a production run that had lasted 15 years. And when the lines at Banner Lane finally stopped making the 135 in 1979, the replacement model confirmed a simple truth. They couldn't actually improve it. The M240 was just a 135 wearing a squared-off suit. The engine, the transmission, the hydraulics, identical. The engineers realized they had hit the ceiling of efficiency. They could update the styling for the 80s, but they couldn't engineer a better solution. The factory lines in Coventry may have switched over to the new sheet metal, but the heart of the 135 refused to stop beating. Instead of fading into a museum, the tooling was packed up and shipped out. It was designed to create an empire of clones that would keep the 135 alive under a dozen different flags. When the lights went out at Banner Lane, the 135 didn't die. It simply emigrated. The heavy tooling, the stamping dies, the casting molds, they didn't go to the scrapyard. They went on a world tour. They found new life in factories like IMT in Yugoslavia, Ursus in Poland, and Tafe in India. These weren't cheap knockoffs. These facilities adopted the soul of the machine. You might know them as the IMT 539 or the Ursus 3512. But look past the badge and the paint job. Pop the hood. The mechanical heart is identical. The pistons, the pumps, the gears, it's all 135. This was a licensed continuation of a design the world refused to let go of. And that survival is exactly why this tractor is worth its weight in gold today. We are living in the era of subscription farming. Modern tractors are drowning in sensors, ECUs, and emission systems. If a sensor fails, the machine goes into limp mode and you can't fix it. You have to wait for the technician with a laptop and a proprietary software license just to tell you what's wrong. In that context, the Massey 135 is the ultimate thumb in the eye to planned obsolescence. It represents mechanical self-reliance. It doesn't have a computer. It doesn't have a limp mode. It is a machine you can fix with a hammer, a 9/16 wrench, and a basic understanding of how gears turn. That is why they still fetch high prices at auction. You aren't just buying a tractor, you are buying independence. The Little Giant proved that a design from the early 60s could outlive the corporate suits that created it. The badge on the nose changed to speak Serbian, Polish, or Hindi, but the rhythm of that Perkins engine remained the universal language of farming. The 135 didn't end up as a static museum piece. It is still out there, right now, in a rice paddy in Asia, a vineyard in Italy, or a hobby farm in Ohio. It is still turning diesel into noise and torque, proving that while technology changes, good engineering is immortal. Banner Lane might be silent, but the heartbeat hasn't stopped. From the Tafe lines in India to the IMT workshops in the Balkans, this 50-year-old design is still the daily driver for half the planet. Albert Thornbaugh's $30 million gamble didn't just save the company, it set the standard. It proves that you don't need a touchscreen to farm. You need iron, oil, and a design that refuses to quit. Modern tractors have limp mode. The 135 just has work mode. So be honest, will your modern machine still be running in 50 years? Tell us in the comments, is this the greatest tractor ever built or just nostalgia? And for more iron that refuses to die, hit subscribe. We'll see you in the next one.